webinar. You have entered as an attendee.
Hello and welcome to this webinar, When is a unit test not a unit test? I'm delighted to welcome testing guru James Salt from InfinityWorks, who will take us through some code examples, samples in Python and re-engineer them to be not quite unit tests that run easily and are easier to maintain. There'll be a question and answer session afterwards, taking us through to the session close at 7 o'clock. Please do use the chat box in your GoToWebinar control panel on the right side of your screen to ask questions as the talk progresses. And James will discuss as many of them as we can fit in after his presentation. So can I please hand over the screen to James? Welcome, James.
Hello, it's great to be here. Now, can I take over the screen smoothly? Yes, I can. That's the first step. Can I hit present? Yes, I can. This is all very new to me, delivering a talk remotely, so bear with me a little bit. I'm also in my home office, which people normally notice that I've got a counting chart behind me. Might like to also notice that. I got an 8-year-old, and when he was a little bit littler, we used to use the counting chart, but now it's just there for posterity. So yeah, so when is a unit test not a unit test? When it's a jar. And the jars get full of technology and tools and possibilities and all those kinds of things. The re-engineering that I promised in the blurb is more of a kind of talk through rather than actually live coding it. But we will go through and try and think about how we could do those things. Try and leave plenty of time at the end for questions. So I believe the talk should take 35 to 40 minutes to get through. So hopefully it's not too dry. I've been a bit worried about this one, so you know, we'll see how it goes. Okay, so who am I? I think I was described just briefly, very generously, as a testing guru. I definitely don't think of myself that way, but it's very generous to be described that way. I've given a number of talks on testing over the years, and I've trained well over 100 people how to test software, how to do automation, all those kinds of things. And over that period of time in my career, I've kind of mostly written Python. I've done some Java as well. I don't mind Java, it's okay. Although Kotlin's pretty cool now, but I haven't got a chance to use it professionally yet. Just recently I picked up TypeScript, which I think is a wonderful alternative to JavaScript that provides a better basis for producing software. It's from a lot of AWS solutions partnering with our clients, and I've been super happy to work with all those things. I've also worked with Azure Cloud and Google Cloud, various other bits and bats. Big lover of DevOps, and a big advocate for visualizing your work. So that's what that horrible Kanban board that I picked off Google is there to represent. I think it's very important to try and visualize things and not just keep them in your head when you're trying to manage stuff. And unfortunately, as time goes by, you do end up managing stuff more and writing code less, but that's not what this is about. This is about the fun bit of the job, as I like to think of it. So the first thing is, well, why does it matter if it's a unit test or not? What's the point, right? Like, what are we actually benefiting? Is it just a language thing? Is this like bike shedding? Are we just sitting around saying, oh, I think the bike sheds were red and I think they were blue. Oh, that's very interesting. I don't think so. Obviously, I've decided to put together a 30-40 minute talk about it, so you probably can guess that I think it matters. And I don't think it matters just because I'm a pedant, although I am a professional pedant. I think it matters because generally different people use them, look at them, care about them, based on whether you call them a unit test or not. So the perception is that a unit test is generally written by the author of the code it tests. So it's written with with design in mind. It's a white box. They've got access to everything. They've even got access to things they haven't written yet that they're imagining writing and imagining needing, which they might have built into their testing needs and desires, which is great because it gives them all the power to express their intent through their tests, which is fantastic. A unit test is not generally looked at by testers, so people who are employed primarily to assess the quality of a solution as opposed to primarily to build a quality solution. And I think it's a very crowbar separation, certainly is at InfinityWorks, but it's kind of a crowbar separation across the world in a lot of places, unless you've got a separate QA department for whatever reason, your business process requires it. If that's just efficient for the way you run things. But if you're working in cross-functional teams, somebody who's primarily there to make sure the software is of high quality and somebody is primarily there to build the software at high quality, they're very similar really in terms of intent and what they care about. And yet testers largely will not look at unit tests. In fact, a lot of the time I can remember going into jobs or consulting gigs and asking, hey, so where's your pyramid at? You know, do you write lots of unit tests? Do you write lots of integration tests? Do you write lots of system tests? Do you do lots of exploratory testing? And they'll go, no, we don't worry about the unit tests, mate. That's a developer problem. So it's still a really strong cultural thing. So I'll try and get through these a bit faster now, otherwise I'll genuinely run out of time. So written during the detailed design and implementation of the feature. Again, you've got full rich white box access to everything, all the intentions. Run regularly throughout development on the author's machine. So you're not going to go weeks without finding out that they've failed. You're going to go minutes, hopefully, hours if you're not very lucky. During code review on the reviewer's machine, it's often at least looked at, or the results looked at, and sometimes executed. I know I like to execute the unit tests when I do a code review. It does mean it takes a bit longer, but if CI hasn't done it for me, I definitely like to do it. And on a distributed version control system check-in, so Git or whatever you're using, pretty much Git in the world now. Although Mercurial still good, right? This and be unique. And the tests are fast. The unit tests are fast to execute. There's a reason they're fast to execute, right? The people that are writing the code are very good at writing code, and they're also doing it in line with writing that code. So if it slows them down, they're going to stop doing it. So they're generally very fast. Slow tests get moved to other test suites like integration tests or slow test suites or whatever. Unit tests are normally kept pretty fast. So on the problem side, you know, it's not necessarily understood by the business. In fact, I've never seen a business person that understands and reads unit test reports. It's not run during a release process generally. The results from a previous run might be extrapolated, but it's not generally rerun. It's not reported generally beyond the developer and the reviewer. So nobody kind of bubbles up that information and makes it visible, although you can do these things. So I think it's important because if you call it a unit test, different people will look at it, different people will care about it, it'll mean different things to different people, and that's important, right? Because we're trying to engage with people and communicate our intent on why we've built the software, the way we've built it, and what it does and doesn't do. All right, so enough, we're getting to the end of the waffle stage of the talk, but a bit of theory goes a long way. One of the unit test sort of axes is this classicist versus mockist debate. So between the Detroit school and the London school of unit testing, you can read about it online. It's not particularly thrilling, but as a former student of history and politics, it's quite interesting to look at the fact that these things exist within IT as well, even in something as benign as unit testing, right? And the basic difference is the classicist is looking at the system as the thing that they're building, and the mockist is looking at the unit as the thing that they're building. So a mockist might say every system is composed of units that work. So if I make the unit work, then it's very likely the system will be able to be made work, even if it doesn't work immediately. Whereas classicists might say it doesn't really matter if your units work in isolation. I think we've all seen that image of two drawers opening into each other, you know, 2 unit tests, no integration tests. It matters if the system works, because that's what people are actually using, and that's the thing that matters. And it matters if that system's easy to understand and describe. And all this abstraction and unit testing and separation of things gets in the way sometimes. I think it generally does get in the way sometimes of describing what the code does, particularly if you have to get into complex DI frameworks, or you have to load a web server in a test context, you know, with a complicated XML set instruction. It can be painful. You have to spin up various things that mean that you're in a unit test context, but you're not in the true app context. So then on to context. Another interesting debate in the testing community is context-driven testing versus process-driven testing. So I think everybody thinks of process as bad. I think that's a healthy general opinion to hold. But it's worth thinking about what's bad about it, right? What's bad about it is it removes agency. It prevents us from doing what you think is right. The context-driven approach, on the other hand, challenges people to be responsible for things and try and find problems and try and fix things. The process-driven takes people down the road of saying, well, I've done everything I said I would do. If it works, then it works. If it doesn't, then it doesn't. So there's a kind of abdication there of responsibility. But whenever somebody says, hey, I want your unit tests to have a 95% coverage rate on this kind of, they're process driven. That's a process driven metric. Some of them are useful indicators, some of them are not, right? The context driven one, well, it only works if everybody understands the context and cares about it. So you've got a load of people that are relatively junior or just don't care, they're going to struggle without a bit of process. So there you go, there's a bit of theory, a bit of background. Let's crack on. So what can we do with unit tests, right? So when is a unit test not a unit test? Let's try and figure that out. So the first thing I thought was, well, have I ever tested something that was effectively infrastructure as code with unit tests? So infrastructure as code unit tests is a fairly silly idea. You know, fundamentally, you're depending on something that builds systems for you, and it's the system that you want. And the thing that you're unit testing against is whatever abstraction boundary that controls that system that you've got is. So I remember a long time ago, unit testing Puppet deployables and ways of managing infrastructure with Puppet. And it was effectively static checking. It was effectively saying, oh, I've validated this and that works, and it looks like this will work and all that kind of stuff. And you can do the same with CloudFormation. You can say, hey, is it valid CloudFormation YAML? In fact, you get your IDE to tell you that more or less in real time, which is great. But that's not really testing as such, right? That's like one step down from testing. So this is an example of a test where we're actually mocking out the whole of S3 with a library called Moto. Moto is a Python library. It's kept really up to date. It's pretty reliable at replacing the Amazon APIs. I've found a couple of problems with it that have then cropped up when we've tried to deploy it, but I think maybe it's really saved me a lot of time. So I'm working at the moment in a pair of teams, and one team in that pair is using this approach. The other team is not. The other team is using the general kind of go all the way to AWS approach before they test any of this kind of stuff, or spin up Docker containers locally. And they spend a lot of time maintaining, writing, authoring, configuring those Docker containers, and they spend a lot of time debugging their CloudFormation deployments and all that kind of stuff that we don't spend. That the team I happen to lead don't spend, because we have this, and it just prevents a load of really quite basic issues from getting in the way of stuff. And it proves that it theoretically works, which is nice. It helps to communicate intent, and it's quite useful. Well, what does it prove more than, we could just assert that we've called the right bits of the Moto API. Like, why is this better than that? Well, the first reason it's better than that is you can do it in 10 lines, right? You can do it in 10 lines of code. You don't have to mock 20 things yourself. You don't have to deeply understand the contract that you're mocking against. The library's doing all that side of things for you. And the great bit about that is that you're actually more inclined to write the tests, and you're more inclined to run the tests, because you can look at them and not like want to claw your eyes out after 10 minutes. So this is an example that I whipped together because I couldn't really show you any code from the project I'm currently working on, because I'm actually on annual leave at the moment and I haven't had a chance to talk to the client. So I didn't want to show you anything true. So this is just a mocked up version of it. You can see that we're using the data class. I love data classes in Python. They're fantastic. If you're not familiar with them, there's a great talk about them from about a year or so ago that introduces them. But they basically code generate your equals method, your hash method, all this kind of stuff, so that you don't have to write those things. You don't have to test those things. They can't really be wrong. And then the other thing that I'm doing there is I've got some type annotation against those fields, just to kind of say, well, key is going to be a string, value is going to be bytes. That again prevents me from having to unit test some of those things, because I can rely on the type system to some extent to provide that guarantee, which is great. So that's the first example. At this point, if it was an audience and I was in real life, I'd kind of look around the room and I'd maybe invite a question, but we'll save those for the end because wouldn't know how to do that in this system. So you can use this as a container backend from any other language, but really the value is if you write in Python, because then there's no overhead to it. It's just as fast as a normal unit test, which is pretty cool. So what about UI look and feel? That's notoriously hard. I did a talk recently at Infinity Works quarterly conference about pixel perfect UIs and how difficult and annoying they are to test and get right, and how important it is to care about them and test them and get them right. I think we've all been in the situation where if we've been writing the code, you think, somebody down the line is going to write some Selenium test or exploratory test it, and they're going to come back to me in a couple of weeks and they're going to say, this bit doesn't look quite right. And I'm going to go back to the designer and I'm going to say, I've already implemented it. It's been 2 weeks. This bit doesn't look quite right. What do you think? And I'm going to really hope that they say it's not a big deal. Yeah. Because that's the best that you can realistically do, unless you've got the designer sat next to you and you're writing the tests yourself that prove out the design. You'll do your best to go through and check them all visually. But modern single-page web applications are so complex, particularly if they're driven by a CMS that has like a dynamic, like a cache in front of it. It's very complex to get these things right from a single manual test cycle. You've got all the different devices to worry about, all that kind of stuff. This is the snapshot testing approach that we're seeing here. So we're looking at an article, which is called the standard article, that has 2 flavors effectively. It has a mini and a MIDI. And what this actually is a link out to the full article that gets displayed with different prominence and different sizes, different images, all that kind of stuff, based on whether it's a mini call to action to go through to the article or a MIDI. And there's another one which is a maxi, funnily enough, but that's a completely separate class and test, and I was already running out of room on the slide, so I left it off. You can see this interesting link mock that we've got to do here. That's an artifact of the way that the next link works. Yeah, I can't fully explain why that is necessary actually, which bugs me. But it is necessary, unfortunately. At least it was when the code was written. This code was written about 4 months ago, I guess, for a different project. And you got this test renderer, and you come through, and you're basically saying, show me what you would generate in terms of CSS and HTML and all that kind of stuff if I was to call this function and you were to send it to the browser. So it's giving you the ability to exact match a string. And normally, exact matching a string, not a great idea, because the string can change subtly, it can break in unknown ways, all that kind of stuff. But as an alternative to manually testing hundreds of components and how they interact on a page across, maybe 5 to 10 device sizes, it starts to become a bit more persuasive. The one downfall of this approach is that you have to be pretty stringent about, if this test fails, what are you going to do? Because match snapshot will fail for a number of reasons. It might fail because an unrelated component has changed and you happen to be looking at a snapshot that includes that component. Like, let's imagine that inside of this standard article, there's something that encodes an image with a caption on the bottom, and somebody goes in and they change the caption component so that it's like italic text, right? That's going to break this render. And it should break the render because the look and feel has changed. But it's kind of a small problem, right? And they're probably changing it because they're updating according to a new design, which basically says all captions need to be italic. So you find yourself again in a conversation with a designer, but at least you're in the conversation 2 weeks earlier than you would have been, right? You don't have to wait for the manual testing to finish. You don't have to wait for the Selenium to finish, and you don't have to have bugs that annoy designers, you know, that just linger around that you can never get rid of, that like deep in your soul, you just feel like you're accumulating all these little niggly frustrations. Maybe you don't feel that way, but I certainly did when I was helping to write this stuff. So the other thing is that this is based on the idea that you're going to generate something which is basically browser independent. Now, flattening all the browser default behavior is good practice in front end, in my opinion, but it's not common practice. And there are a number of shims and things like that that you need to put in that makes the browsers as similar as possible. Hopefully you're not in like an IE whatever world where you need to cover browsers that are considered legacy by the industry. But if you are, then there are shims that you can put in that will be generated, and you can assume that the best variant of what you're doing will be generated by those shims. If you end up writing the shims yourself, then you have to test them yourself, and then it gets more painful. So again, this is a unit test, but it's a unit test for design, so that's a bit weird. The previous one was a unit test, but it was a unit test for infrastructure, and that's very weird. But they're both possible. You can do them both, and they do replace some amount of effort, I think. But what about interactions then? So all right, yeah, I can tell the screen looks okay. I could even go one step further and have like screenshot comparison tests. I didn't include that because we didn't do it on that particular project, but you could do it and it'd be valid and it'd be valuable. But the actual interaction of the page is what matters. A lot of WebDriver tests, a lot of just clicking through pages, trying to go on a journey from A to B through Z normally. You can simulate this by just making sure that all the links work and go to the right places, because that's fundamentally all you're really doing. You're only validating that somebody's populated the link properly and that the page on the other side of it doesn't 404. So if you've tested the loading of every page and you've tested all the link references, then the only other thing that can go wrong is something in your actual web server logic, which is not really a front-end problem anymore, right? It's like, how is the front end being served? And if you're serving like a static page in S3, then that's not a complicated picture. I mean, I know you can get CloudFront and geocaches and all this kind of stuff, but a simple version, it's not a complicated picture. You're basically serving a static file. If you're serving something dynamic, then okay, you've got some CMS type things, but again, it's not a front end issue. So you're not really testing a front end interaction. You're testing the system. You're testing whether the front end can get to the right bits of the back end and whether those bits are responding fast enough and with the right kind of data and all that kind of good stuff. And you do need to do that, but I would argue that you could have a set of unit tests for that as well, and you could kind of do the majority of the work between those two sets if you wanted. I'm not saying you should, I'm just saying you can. So that's like three novel examples, right? So they're sort of loosely connected by the fact that they're weird. Two of them are UI and one of them is kind of back end. And they depend on these libraries and tools. So they depend on the Moto library, or they depend on the React testing stuff, snapshots, things like that. So they're not straightforward. You can't just, it's not JUnit. You can't just spin up the code and assert things. You've got to kind of have this framework behind you that will help you to do it. But the framework's not as heavy as other alternatives are. And I would have liked to include like an app testing version of those things, but it's been so long since I've done app testing that I couldn't find the code that I wrote for the equivalent stuff on Android. So here's a toy problem to explore. This is a bit more connected. It's a bit more back-end oriented. It's essentially we want to cache and we want it to have the following features, and we're not allowed to cheat, so we can't just import somebody else's cache that already does all these things. Obviously, if this was real life, we'd cheat because it's the best way to succeed in programming. You know, Google for it, at least spend 20 minutes trying to figure out if somebody else has done exactly what you're looking for, because it happens more often than you'd think. We need to be able to cache a value of any type against a string. In some languages that can be challenging, but in Python that's pretty trivial. You know, generics are a thing. You can always get there if you really need to, but it can be a bit more painful than it is in Python. Able to invalidate the cache on access for a key that was created too far in the past. Pretty simple, classic invalidation. You know, your value is too old, you should go and get a new value rather than getting it from the cache. Able to invalidate the cache on access for a key that's not been accessed recently. So this is some kind of proto recently used cache idea. Able to invalidate the cache on access for a key that is not one of the most recently accessed keys. So this is like you're trying to limit the size of your total cache to being a reasonable size that you can predict, that you can work with non-functionally. Because if you only did number 3 and you didn't do number 4, then you'd still have an infinite cache potentially. You'd still have a problem with cost if you were doing it in AWS or whatever, or with time and size if you weren't doing it in something that was as extensive as AWS. So those are the 4 things that we want. So let's write some code, right? Or let's show some code that has been written that I wrote earlier, Blue Peter style. And I got some quotes on some of these slides. I wanted to try and find a pithy quote for everything, but again, it's like there's only so much time. There definitely are ideas behind this that flow through, and hopefully you'll see those. So here's a really simple starting point to solve that problem: a cache value class. So we know we want to be able to store any value against a key that's a string. But actually that's 2 separate things, right? We want to be able to store any value. And if we look down ahead at our requirements a bit, we know we're going to need to relate the time of access to the time of creation and the time of access to the time of last access. So we probably, alongside the value, want to store the created time and last access time. And, you know, Yagni may apply here, so you ain't going to need it. It might apply here. We might have been better off starting smaller. But there's nothing valuable that's smaller than this, I don't think. We know roughly what problem we're going to solve. We can kind of predict it up front. Like if we were TDDing it properly, we might have gone through a few steps here, but it's no big deal. On line 9 there, you can see that I'm using the any type from Python's typing, just to indicate that value can be anything. And then I've got 2 fields there that are calculated. So on line 10 and line 11, there are 2 date time fields that are calculated. And what that means is that the constructor and the initializer do not initialize the values of those fields. They get initialized in the post init method, which is a special method on data classes that runs post init that allows you to produce generated fields effectively. Or you can also default things and all sorts of other things, but I found this the most useful on the init false, and then just initialize them in the post init. And what we're going to do there is we're going to take now and we're going to set the created and last access to now. So we're kind of making the assumption that when they produce the cache value, that's when they've accessed it last. I think that's a fairly reasonable assumption, but it might not hold true. You know, it might be slightly wrong, which point we'd have to change our implementation. But that's the assumption that we're making. I've got this inflammatory quote by Linus Torvalds, who, you know, inflammatory quotes, Linus Torvalds goes together, where he basically says you're bad if you don't care about your data more than you care about your code. I think there's some truth in this. I mean, there is some truth in this, to be honest with you. Code is much easier to change than data. Anything that has a history and a storage and a format that people are expecting becomes harder and harder to change the longer it lives, the longer it exists in the world. So just getting the structure right, just getting the core bit of the data right is actually, I think, probably more important than how you code around it and how you use it. But it's this inside out approach, it's this mockist approach that we're going down here. We're kind of saying, well, actually, I want to start with the smallest bits of my system, make sure that they work, and then I want to compose them together. And that's kind of where we're starting. And I just did this as an exercise, and this is where I ended up. So I didn't deliberately decide to go down that route, just the route that I actually went down when I implemented these things in order to talk about them. And then you got the Fred Brooks equivalent about tables. Ostensibly, it's about tables and flowcharts, but really, again, it's about data and procedure, or data and logic, however you want to describe it. And I think it will be obvious. Like if you look at this cache value, you know that because there's a create at and a last access, that you're going to care about those things, right? It is signaling that to you. So this is the main, sort of the most important test that was written for this. And again, it's not a very long test, and it's not very complicated. You'll notice that there is use of datetime. So we have mocked out the response of UTC now within the context of our library, which is called simple, because I couldn't think of a better name when I was creating the file. And then we are creating the cache value and making sure that we can get it back and it works, all kind of good stuff. Because we've mocked out the datetime, when the cache value is created, it will get exactly that time, which is why we can do exact assertions there rather than having to do a race condition effectively in our unit tests. You never really want to introduce variation like that into a test, but into a unit test in particular, there's no real reason to. It is worth saying that there are some languages where you might have to get into dependency injection here. What we're doing is monkey patching. So we're basically taking the namespace of datetime and replacing the UTC now's name associated value with the associated value of a mock, and then setting the return of that mock to be our expected now time, which is kind of backwards DI. You know, you're inside the code that's running within that with block, you're dependency injecting UTC now's response. Whereas a lot of languages, a more natural idiom might be to have a clock that is provided at instantiation time of the whatever it is, which kind of again goes against this mockist philosophy, because you're starting with the more of the puzzle there. You're kind of saying, well, I need to know what's going to access the cache values, because it's going to need a clock, or cache value is potentially going to need a clock when I initialize it, and therefore I need to know a bit more than the minimum unit. So yeah, but it might be more idiomatic to do that kind of thing in some languages. So let's take the other half of the problem, right, and start working on that. So we've got what we think our cache value is going to look like. We've built that up, and now we've got an age cache. So this is just the implementation of 0.2. You know, if something's too old, then it doesn't get a hit on the cache. So the first thing to notice is this age cache is pretty coupled to our cache value. Basically, what we do is the caller of the age cache uses any value that they want, and we turn it into a cache value under the hood. So we kind of have to know a fair amount about the implications of cache value. Now we could get around that by in the init having a kind of a container class that is provided into the constructor that then basically says call your container class constructor with the value, and it should work. And then you've got a contract of, as long as I've got a class that can be constructed with a single argument of any type, then I'll just call that every time. But that to me was a bridge too far in terms of making it general purpose and composable and Mockist and all this kind of stuff. What I instead went for was just encoding the cache value in, because that's the one that I think I'm going to predictably use. And I don't think it's too painful to rip it out later if we need to. So the other thing to notice here is that we're descending from dict, which is Python's built-in dictionary type. That's giving us a lot of code that is incredibly well tested that we don't need to write. And every single time we can, we're using those dict methods in order to make things work. So you can see on line 34 and line 33, when we actually want to invalidate the cache, because we don't want to, we want to propagate exactly what would happen if you try to access that key and it wasn't in there. What we do is delete the key and then access it, and it'll produce exactly the same behavior, no matter what the behavior is that people would expect from a dictionary. So we could raise a key error there, but why would you? Because then you've got to test it. You don't have to test it if you're just calling things that already exist and have been tested elsewhere, not to the same extent anyway. Again, we make sure we take now only once. It's just good practice. And we know about the internals of our cache value model, and that's a pattern that's a bit weird, right? So generally, the cache value would want to determine whether it was new enough itself, because it would be within its responsibility. But that cache value is actually a value object, so it's never designed to hold behavior. It's only designed to hold state. There's a whole bunch of articles online about value objects. I really like them because they allow you to keep your data structures relatively simple and clean and free of unnecessary mutation. So yeah, I once described it as my static final phase to a colleague at a previous company. I'm well beyond my static final phase now, but I still quite like things to be fairly simple at the data structure level. And then we update the last access value, because you probably should, and then we return the value from the result. So the caller doesn't even know there's a cache value going on there. It's kind of hidden as an internal implication detail. You've got a max age, which is overridable up here, which gives us a bit more expressiveness and power. Here's how we're going to test that. I'm really running out of time, so I'm going to whiz ahead. We just have a then, which is the now with the max age, with a time longer than the max age added onto it, and then we carefully mock the times so that we can detect that a key error is there, and then the answer is not in the cache anymore because it's been removed. So we don't have to do that in future. So here's another version. This is 0.3, so the recent use cache. This is caching things based on how recently they've been used. We're not being very dry here at all, right? I've not pulled out a common base class. I've not refactored for any kind of meta programming here to account for the fact that these are, if you squint, basically the same lines of code with slightly different variable names and slightly different comparisons. I think you could do that, but actually, rather than being dry here, we're trying to be wet. We're kind of saying, well, it's worth explaining twice. It might be used and evolved in two different ways. It's not true to say that every car is a Ferrari. Maybe we should have a car and a Ferrari rather than a car that is a Ferrari that is a car. I don't know. It's difficult. It's a modeling problem, but I've gone down the road of being rather wet about it rather than dry about it. And there's this quote here about executable specifications, which I think sort of is where I'm coming from philosophically. Alistair Scott, I think he was a consultant at ThoughtWorks. And so he's basically saying here that he's making an argument for BDD actually, but in a smaller sense, what he's saying is if you're describing something, then make sure it's up to date and accurate to the thing that it's describing. And if what you're describing is an abstract base class, then it's very hard for it to be accurate and up to date. Lots of people want to change it and fix it. So here's another one, a fixed size. This is for 0.4, 0.5, a fixed size recent use cache. So it just combines the two things. And here I have descended from recent use cache because actually the get item is exactly the same, but the set item is different because we only ever want to have a number of items held in the cache. So if the length of the cache is equal to the max size when we try and add an item, we need to pop an item out. And all I've done there, rather than actually care about the time signatures and how old they are and comparison and go through and loop them, is I've just stored them as a first in, first out queue, the normal queue in Python. To think about those words in my head, and I've said the max size of that queue should be the same as the max size of the fixed size recent use cache, which is a wordy name, but I couldn't come up with anything pithy. So when we go through and delete those items, then obviously you have a slot available, and we go through and put them in. You notice that on line 69, we actually set the item in the underlying dictionary before we adjust the guard effectively, the thing that means there's only 8 of them. So that means there is a period of time every cycle where there are 9 of them in the actual dictionary once you get to a certain point. The reason that we do that is that that method might go wrong. And what we don't want to do is we don't want to have to recover that transaction in any way. So we kind of optimistically write to the cache, and then we check that we should have done that by checking the max length, right? And in the case where actually we've exceeded the length of the cache, we then delete the oldest thing in the cache, which is probably the right way around. So here's how we tested that. Again, because we don't need to care about the times, we can not do any mocking in this one. So we can be pretty classicist about it and just go in and say, this is what it should do. Let's not worry about mocking anything. So I'm well over time. So I'm going to sum up with a nice picture of the matrix, which is always a good one. So you can absolutely call anything you want a unit test. So I've gone through some examples there. UI look and feel, and also the UI interactions, and also the AWS stuff, which is great. And then I've gone through the sort of slightly longer example at some pace and gone, well, actually, here's how it would implement in kind of more of a back-end context. But if you're trying to prove some integration or experience or feature, then you don't need to take it all the way to calling it a unit test, because it might cause people to ignore it, might cause people to skip over it and not care about it. And if you test software for a living, either as a developer or a tester, you really should be able to read and understand what a unit test is. So when people make the mistake of calling it slightly the wrong thing, you can tell, and you can actually go, I don't need to write this other test because they've written this test over here, or I do need to write this because actually they're very, very mockist, and therefore I need to integrate the system at least once because they've never done that. So it's important to do that gap analysis. And there we go, a little bit over time, I apologize, but I'm ready for questions.
Thank you very much for that, James. Now, if you have questions for James, could you please put them into the questions/chat box on your GoToWebinar tool panel. We do have some questions for you, James. First of all, there's 2 questions that I can roll into one, really. Does your approach that you've articulated replace anything? Is this way of thinking additional, or is any effort replaced? Another way perhaps of putting it, do you think testers writing unit tests can add value?
Do I think? Yeah, I mean, I certainly think that testers reading them and understanding them adds value, because it removes duplication of effort, and that is often the bugbear of test cycles, in my experience. You want to spend your time finding problems and defects, being context driven and not process driven. In terms of the sort of rounder point, does it remove anything? I think it's a good question, right? It's quite difficult to answer, in fact. I guess from my point of view, if you do more unit testing with more mocks, you are more confident earlier in the units of code and how they can be composed. It doesn't necessarily translate to being more confident in the system. But a good tester should be able to look at what you've done there and turn that into a gain in terms of understanding the system as well, I think. So I think, yeah, I think there's some value in it.
And another question. Oh, bear with me. I have lost my question panel. There we are. I've recovered it. I'll put it on a different screen. One of our audience points out, and I'm sorry about this, everybody. We have had a difficult connectivity. James, you've cut out at odd times. Basically, it's been okay from where I've been sitting. One of our audience points out that it keeps cutting out, so forgive me for asking. But what about the use of solid principles within coding and testing?
Yeah. Yeah, there's a good principles. I didn't cover them in this talk. Yeah, there's a whole bunch of design principles that are good to follow. Yeah, if you like, I'm not really sure where that question's going. Yeah, they're good principles. I like them. But
the questioner might enlarge on it. I'm afraid I can't
yeah,
ask
that'd
him
be
more
great.
than his
like, if there's a specific angle of that, yeah, that'd be good.
But we've got another one. What about this? What proportion of time should be dedicated to unit testing if using a mockist approach in a typical project with cloud and web apps in comparison to system tests, SIT and UAT? Is time invested early in this going to provide earlier integration defects and fixed earlier in SDLC?
That's a fantastic question. So I think that the best developers I have ever met, so I'm a pretty average developer, the best developers I've ever met will describe 50 to 70% of their time as being spent either testing something or designing something, which design is kind of I think that design is a test process, but that's because I'm a tester, so I've got a bit of a test-centric worldview. But basically, rather than actually executing on the implementation of the problem, either assessing their execution of the implementation or thinking forwardly about that execution. So if you think an average team is 4 developers and 1 to 2 testers, right? Which in my experience, it generally boils down to, then if your developers, if the best ones are spending 50 to 70% of their time doing unit testing, then that's going to exceed the amount of time you spend doing the other kinds of testing quite quickly. So I think it's true to say that you will spend more time doing unit testing than you will spend doing certainly SIT. UAT is a different one because there's a number of different models for UAT, and the ideal model would be to get real users to test it, right? At which point it's not really costing you time in the same way. It's kind of costing organization and overheads in that sense. And you can get third parties that will organize UAT cycles for you and deploy apps to people and all that kind of stuff, which is a fantastic service. So getting back to the point, the one tester on your team spending time understanding those unit tests that the best developers have spent 50 to 70% of their time writing is going to save that tester time and effort, and is going to make sure that they understand and they're in sync with what the team's producing, which will lead them to spend more time being context driven, trying to find defects and trying to find things that people have missed. So I think that this will save you time across the SDLC, yes. But I think actually people underestimate how much time a good development team spends unit testing software.
The last questioner has clarified with solid, he meant from the angle of keeping the code structured and clean over having repeated tests due to unreadable code.
Yeah. So let's talk about interfaces in solid, right? I can't remember exactly what it's referred to, I think, interface separation or something like that. You're basically saying that you want many specific interfaces rather than one all-powerful general purpose interface. If you have one all-powerful general purpose interface, the unit testing for that tends to look like spaghetti junction, because you've got a lot of things happening within a single method. The methods are quite complex. You want to kind of separate them out. You've got God classes that do basically everything. So it's definitely true that there's a relationship between your application of good design principles and the ease of unit testing. So like I say, in the interface principle, I think that shows itself a lot. The open close principle is the one that I struggle with the most, because sometimes tests need things to be a little more open than other things need them to be, and it can get a bit awkward. But yeah, I think that there's a good strong relationship there. Certainly, if something's easy to test, it's more likely to be well designed than if it's hard to test, and much more likely to be well designed. But I don't think it's like causal. So I don't think because something's easy to test, it's been well designed. And I don't think everything that's well designed is easy to test either. I just think there's a correlation between those things. And generally, people that care about things like solid principles also care about the extent to which they're mocking in their unit tests, and the extent to which they're exercising the underlying system and all that kind of stuff. So I think there's a good relationship there. I hope that's an answer to the question. Thank you for clarifying the bit of the question you wanted answering.
Interestingly, the questioner follows up with this. Is it better to use test-driven development overall when developing applications or software?
Oh, you're getting into a religious argument there. So I like spaces and not tabs, and I like test-driven development and not testing after the fact. I think both of those things are religious principles, and I've met excellent developers that are the opposite way around, that prefer tabs and prefer to write tests after the implementation's more or less finished. And that, I think, to do is with how you design things. So again, I'm a very bottom-up designer of things. I want to quite get my little components right because I can understand those, and I find it easier to understand those and compose them. Whereas if you're more of a natural architect, you're more of somebody that can imagine the big picture and the system and how it hangs together, then it's hard for you, I imagine, to step back and go through what seems like the tedium of TDD. However, even though I've met people on both sides of the spectrum, I think generally, if you're an average programmer, like I would say I am, TDD benefits you massively, because if it's guardrails for you to solve the problem and not solve an imaginary problem, and that's one of the biggest time sinks if you're relatively new in your career or relatively average at it. One of the biggest time sinks you can get into. If you can keep the whole system in your head and you're a natural architect like that, then I think you probably can write the test second and it can work out for you just fine. And I've met people that do exactly that and they're great.
Here's another question, James. Much of what you've shown during your presentation is very back-end, not much UI. What if the problem was more at the front end? Does this same logic apply or work for more visual types of programs?
It's harder to apply, right? Because there's a bigger surface area for those intangibles. So in the sort of longer example, I deliberately chose something that was quite back end and small and a toy problem really. You can do those things for front end stuff and UIs and looks and feels and all that kind of stuff. But if what people want from it is a sense that you've built something beautiful, and they can't tell you exactly what beautiful is, then you'll never solve that with a unit test. If they can tell you, here's my design, here's what I'm trying to get out of it, I can encode that and talk to you about it, and we can agree on it, and then you can store it in the page and check against it, and great, you can do it in a unit testing way. But if it's more exploratory and you're more finding out what the right thing is, then it's necessarily impossible to unit test. You have to get people involved. So it is less applicable generally, but I think that's largely more because people have an easier time explaining the logic of back-end systems than they do the logic of what people do when confronted with a screen. Yeah, because people are inherently harder to predict than the algorithms for financial transactions or caching or whatever.
Who are the reviewers, asks one of our audience, that check the unit tests are functioning or pass, and what do they do or what do they use to determine if the correct thing is built? She apologised, it's been breaking up. I do apologise to our audience. It's actually got a lot better now, but you were breaking up at times, James, but not sufficiently for me to stop the webinar. What do you make of that question?
Sorry, the question was,
who are the reviewers that check the unit tests are functioning or pass, and what do they use to determine if the correct thing is built?
Yeah, okay, so you can review the code at a number of levels, right? You can say, is this the sort of code that the team produces? So I had one former colleague describe it as it should look like it's all been written by the same person, even if it's been written by 10 different people over a year, right? That's the ideal. And you're looking there at kind of stylistic choices, libraries that you use and don't use, all that kind of stuff. You can review it at kind of the syntactic level and say, well, it looks right to me, the names are good, all that kind of stuff. Or you can review it at the kind of functional level and say, yeah, I think this will work. I like to try and review it at the functional level. It takes a bit longer. So that can be anybody in the team that's not been involved in writing the code originally. And the best way to work out whether you've done the right level of unit testing is go in and read the unit test before you read the code, and actually try to get a sense of, is this specification? Is this something where I can understand what the code is doing at a conceptual level without looking at the code? Or when I look at the unit test, do I get a picture A, B, C, and then I look at the implementation and it actually is like A, B, C, D, E, F, G, H, I, J, K, you know, the bits missing from one. So that's the way that I do it. I go in and read the unit test. I try and think about what I think the code should do under the hood. Then I look at the code and I go, oh, it does all these other things as well, or it doesn't do those things, or whatever. And then I think about how to position a response. So like, hey, do you think you've missed a case here? Is there something here? Or I might write one myself, and give some feedback. Generally, if it's complicated, I like to call people up and sort of say, hey, what do you think? You know, what was the logic behind this? Because a lot of engineers are very conscientious people. They've done these things for good reasons. So it's probably best to ask them why, rather than saying, hey, you missed a unit test here, mate. You're a fool.
There's a quick question as we approach 7 o'clock. Is having the ISTQB certifications for software testing useful?
Useful to whom, I guess. If I was looking for a job, I was looking for my first job in the testing industry, then it would be useful. I would get it. If I was looking to integrate with a traditional testing team who put a lot of stock in the ISTQB, then I would get it. And if I was looking for, if I was, you know, not a tester, and I was looking at how might I frame that? So I might think about like the pesticide paradox, or I might think about various other idioms that are taught in that curriculum, and use it to understand testers and what they're thinking about and how they find problems, then it's useful. But will it make me a better tester? I think that's pretty debatable. It will certainly make me more process oriented, which might be the thing that you require if you're new into your career or you're in a particularly formal environment. But I'm not sure it will make you better at finding problems or at explaining those problems to people, which are the two really core problems of testing.
Well, thank you for that, James, and thank you for a fascinating and thought-provoking presentation. There's a great deal of material for our audience to take away from this session. We will have, we'll share the recording, and if you think of any further questions or issues, please do email them in, and we will do our best to address them for you, or at any rate, I'll pass them on to James, and I'm sure he will. In the meantime, do please complete the survey that will pop up when you close this session, and give us your thoughts on that. And in particular, when in an hour's time, a feedback request email will land with you, asking for feedback as to how we can keep these sessions improving. So I hope you've enjoyed this session. Thank you for attending. Thank you very much, James and Infinity Works, for putting you up to speak to our audience. Thank you very much again, and good night.
Good night.